Alright, in this video what we're going to do is we're going to take a look at functions, and actually what we're going to do is we're going to transform them. Now, as we work through the video, by the end of the video you're going to be able to do that by yourself. You are going to be able to graph the transformation of a function. I put two of them at the end, and that you'll be able to do, and you can actually do those on the coordinate plane. So let's take a look. So if we want to transform a function, let's go back, sorry. So if we want to transform a function on the coordinate plane, remember we're going to be working with ordered pairs. And we will look at how we can translate them and how we can reflect them. And think back to geometry. Remember when we did a translation, or you guys refer to that as a slide, or if we did a reflection, which you guys sometimes thought of as a flip. Remember that our original shape did not change. Remember, they were congruent because these were what we called our rigid transformations. So when we do these today, you'll see that we will move them or we will flip them, but yet they will still keep their shape. So here's the first little graph or function that we are going to transform, and we're going to do a translation. We're going to translate it 2 units up. So if we are on the coordinate plane and we're going to translate up, if we translate up or down, we focus on that y-axis if we're going to go up or down. In this place, up. So in this case, we are going to affect the y-coordinate only. Okay, so we're going to take all these points, and we're going to add 2 to the y-coordinate. So we've got a point here that we'll look at, one here, here, and here. So we're going to look at a table.
Miss Jenny Jones, please come to the main office. You have a phone call.
Okay, let's start. All right, so I'm going to, right here, I'm going to take this point that is at -5, 3. I am only going to focus on the y. Remember why I'm focusing on the y? Because we are translating up on the coordinate plane. The y-axis is the axis that is up and down. So if I add a 2 to the -3, I end up with a -1. So now I have a -5, -1. Over here at my -2, 0, I'm going to add a 2 to the y coordinate. So 0 plus 2 is 2. So now my new coordinate is -2, 2. And at my next point here, at the 0, -2, I'm going to add to the y. So -2 plus 2 is 0. So my new point is 0, 0. And then over at this point here, that's 2, 0. We're going to add 2 to the 0 here, and we get a 2. So new point is 2, 2. And then our last one over here, we're over here at 5 and -3. We will add to that -3. -3 plus 2 is -1. So now we have the coordinates of our transformed or translated function. So if we go back and we put those in, so we're still over here at -5, but now we're down here at -1, so we've got a point there. Now we have -2, +2. Now we're up here. We're scooting on up. You can see what's happening. Now we're at 0, 0, so we've moved this one up. See how we've moved that point up. And then our 2, 0 becomes 2, 2. And then our 5, -3 has now become 5, -1. So you can see that those original points that we started with, we have moved all of them up 2 units. So what's that going to look like? Is it still going to look like that M? Absolutely, right? Because it is a rigid transformation. Okay? And so we end up with those new points. All right? So we just took this and we translated it 2 units up. All right, let's take a look at our next one. And we're going to do a translation again, but this time we're going to move to the right. Back one there. Got a sneak preview. We're going to move this one to the right. So if I'm going to move to the right or to the left, now I'm focusing on the x-axis. So now if we're going to move to the right, we're going to affect the x-coordinate. Okay? So let's make up a table again. So this time we're going to affect the x-coordinate. So we're over here at -2 and +4. I did it again. Hold on. I lost him. Got it back. So we're over here at -2, 4. So at this point, now since we're moving to the right, we are only going to change the x. So a -2, and we're going to move it to the right 3. We end up with a 1. So we have -2, 1. We'll affect the -1 here. So -1 plus 3 is 2. So the new ordered pair is 2, 0. Notice, oops, let me back up. Sorry guys, this one up here is not -2, 4. It is -2, 1. It is 1, 4. Sorry about that. Down here, we're going to affect the x again. So 0, we're going to add 3 to that. So that would be 3. So we have 3, 2. Again, the y's are not changing, only the x's. And then here, if we have a 2, and we add a 3 to that, we end up with a 5. So now we have 5, 2. So what that's going to do is shift this 2 to the right. And if we look over here, we see that we have done exactly that. So this point has shifted 2 here. This point has shifted 2 here. And this point right here has shifted 2 to the right there. Did it keep the same shape? Absolutely, because a translation is a rigid transformation. All right, we're going to look at one more. We're going to look at a reflection. Okay, let me change colors on this one. All right. This time we're going to reflect across the x-axis. Now I want you to think again back to your geometry. If you're going to reflect across the x-axis, you're going to go one way or the other here. You're going to reflect across that. So if I'm going to reflect across the x-axis, remember that it is the y that's going to change. So if I have a point up here and I reflect it down to here, it's going to go from a positive y to a negative y, right? So your x value will stay the same. However, your y will become its opposite. So if I'm going to, again, reflect across the x-axis, I'm going to leave all my x values the same. So if I'm at -2, 4 up here, that x's value is not going to change. However, I'm going to take the opposite of my y. And the opposite of a positive 4 is -4. So now my new point is -2, -4. And then we move to the -1, 0. So -1, 0 here. Now the y is going to change. However, y is not positive or negative, so that point actually stays the same. Our 0, 2, we're going to change the y to its opposite. The opposite of a positive 2 is negative. So new point 0, -2. And that one is right here. So I'm going to move him. And then our last one at 2, 2, we're going to move this one right here. That at 2, 2, we're going to change that y. We're going to change him to his opposite. So opposite of a positive 2 would be -2. So 2, -2. Now we've got those new points. Do you know what's going to happen? Remember, reflections, you guys think of those as flips. Do you think this function is going to look like a flip of himself? Let's take a look. All right, here's our original. Whoops. Here is our original, and here is the reflection. Did it flip itself? It sure did. Did it keep the same shape? Yes, it did. And why? Because remember, reflections are also rigid and they don't change the shape. So we're going to stop there. You can go back and rewatch the video. I'm sorry I kind of messed up a few times. I'm still trying to learn how to use the iPad. But we can suffer through this together. So what I want you to do right here is we have 2 questions, and I would like for you please to work those and bring these back to class. This one you're going to reflect across the y-axis, so you're going to reflect this way. So if we reflect across the y-axis, remember it is the x that's going to change, right? Because if I have a point here and I move him over here, remember the x in this case will go from a positive to a negative. So remember it is the x that is affected. And then over here you're going to translate this one 2 units to the right. So you're just going to move this guy this way 2 units. And remember they should keep their same shape. They should not change. All right, bring this back to class. I am also going to give you a Google form to fill out that will be attached to this, and go ahead and do that as well, and I will see you next class.